All right. Hello, everyone. How's it going? You all ready? They don't sound ready.
No.
Are you all ready? Woohoo! This is a rock concert. No, I'm kidding. All right. So this is the unit economics of AI agents. I'm Guille Ojeda.
I am Andres Moreno. We're both principal architects at Kalen. We're both AWS community builders, and we're both AWS user group leaders.
We're basically twins. He's the ugly one. I'm the evil one. So let's hear a little bit about yourselves. Raise your hand if you have built something impressive with AI. Nice. We have builders in the house. Now raise your hand if you've solved a real problem with AI. Nice. Now raise your hand if you have validated that the value of the problem that you solved is greater than the cost of solving it. Oh, we have a couple hands. Nice. So if you didn't raise your hand, that's fine. That's exactly what we're here. You're all builders. You already know how to build AI agents. And if you don't, there are 100 talks about it today and in every event. What we're going to talk about is how to figure out the unit economics of your AI agent, meaning how much does it cost and what's the value of that agent? What's the value of the problem that it's solving?
So here's what we're going to be working with today. It's going to be a Spanish to English translation agent. I know it's not a super impressive example, but it kind of helps us prove the point that we want to get to by the end of the presentation. So bear with me on this. And also, let's assume there's not a really good solution for this already. So basically, this agentic workflow that we're going to be building is not just going to be an LLM task. We're not just going to give it a PDF to an LLM, and it's going to produce a PDF back for us. No, we've distributed this into different chunks, deterministic pieces of a workflow so that we can get more deterministic results when we're working with an AI agent. So we're basically starting with a Spanish PDF that's going to go and we're going to extract the text, the structure, and the layout to then get the text blocks so that we can translate them to the target language, in this case, English. Once we have the translation, we're going to take all that back and we're going to recompose that PDF and send it to an evaluation gate where we're going to see if it's an accepted PDF for us. If it's not accepted, we're going to go and retry. If that retry doesn't get accepted, we're going to escalate to a human.
We're going to take you through 5 steps to prove the unit economics of your agent. So first, we're going to define the acceptance criteria. Then we're going to estimate the value per unit. I'm talking like this because the microphones are on this side. Then we're going to build a measurable POC, meaning something that actually solves the problem and that we can measure how much it costs. You are going to use it to measure the cost per result. And finally, we're going to iterate a little bit on that POC to improve our margins. And then this last point is for you as homework. You're going to take this and scale it, but only after proving that the value of the agent is greater than the cost.
So as Guille mentioned, we first need to define our acceptance criteria. We need to know what good is before we try to do the good thing. We need to know the rules before we before we follow them. So in our case, our measurement is an accepted document. So how are we going to accept a document? So in our quality or evaluation gate, we're specifically looking to have it in the target language, right? It would be pretty useless if it didn't produce it in the target language. We want to preserve the structure of the document. We also want to preserve the meaning. I don't know if you remember back in the day when Google Translate got released, you would give it a blob of text, it'll translate it, but the meaning would be off, way, way off, right? We don't want to do that. So we want to preserve that meaning, and there's going to be risk tier checks. So depending on the type of document, maybe it's a health document that requires a little bit more scrutiny than just a blob of text or a child's story. So there's risk tiers that moves that threshold for an accepted and a rejected document. And after that, we'll obviously end up with our accepted and rejected document, and we'll get a ratio for how many accepted, how many rejected, that will help us further in the presentation.
So next we're going to estimate the value per unit. And when I say per unit, It means after we had the acceptance criteria defined, we know what our unit of work is. In our case, that's going to be one translated PDF. We are assuming that PDFs have more or less the same length, just to make things a little bit simpler. So to understand the business unit of the agent, we're going to ask ourselves what happens without the agent. Like, what does the world look like before our agent exists? If we're still doing the work, but we're doing it manually, then the value of the agent is going to be the manual effort that we avoided, translated in dollars, of course. If our work would take longer, say we could translate those PDFs, we both speak Spanish, but it would take us 30 minutes. An agent would do it in 30 seconds. So that means our agent is reducing the lead time for that task. Lead time is how long a process takes on a specific step. We also may have capacity limitations. We both do this theoretical PDF translating thing as a side gig, like we both have jobs. So we can only put maybe an hour a day on this. The agent can do it much faster and can scale a lot more. It means it's increasing our throughput. Maybe we're not that good at translating those PDFs, right? Our work is a little bit inconsistent, which is fine if our customers are willing to accept that, but it is a risk. So if the agent is more consistent than us, then it's reducing that risk. And finally, it may be introducing new capabilities. Like we said, hey, we're translating from Spanish to English. What if we want to translate from Chinese? We wouldn't even know where to begin. So the agent would be introducing a net new capability for us, which introduces new revenue. Now the thing is, so you have to do this exercise. You have to think through all of these angles and put all of this into a spreadsheet, but not all of these are going to be real. So in theory, everything here happens. In reality, not everything here translates into actual business value. Say the new capability, yeah, we can now translate from Chinese, awesome. But if all of our customers come from Latin America, then nobody needs our Chinese translation services. So we don't have the ability to turn that new capability into actual new revenue. Same goes for inconsistent work. Say we translate very simple things and we're pretty good at it. So in theory, it reduces the risk for someone, not for us, not a win. Capacity limitations, it does increase our capacity and it does reduce our lead time. But maybe we don't have sufficient leads, we don't have enough customers, and all of our customers are like, yeah, take these 2 PDFs, give them back to me in English by next week. So these are not actual problems for our business. Even though we do get the benefits, those benefits don't actually translate into money. So in our theoretical example, overly simplified business, the only real benefit of the agent, the only business value of our agent is going to be the manual effort avoided. What we're going to do is consider the different activities that go into translating, say translator, reviewer, document operations. We're going to think how long each of these take, and we're going to multiply that by an hourly rate. So we're going to come up with some number, say $15 per document, and that's going to be our manual cost. That's going to be what we measure our agent against.
So now that we have that value, right, we have the $15, we can now jump to build a measurable POC. There's different ways to get measurements for how much your application is going to cost, how much your agent, but a lot of that is theoretical and is just fake, right? So we can get only so far with that. So with a true POC, we can actually get there and get meaningful values. For our application that we're going to show today and the one we're working with for all these measurements, this is the architecture. So we have a user that's going to upload a PDF, a Spanish PDF, and it's going to go into S3. Right after that file is uploaded, we're going to invoke our agent. Our agent is hosted in Amazon Bedrock Agent Core Runtime. This is a service that allows us to host our agents and have it run and scale our agents when needed. Then our agent's going to be using Amazon Bedrock, explicitly using the Sonnet 4.6 foundational model for its inference. And it's going to trigger several tools to be able to accomplish what we want, translate a document. These tools are written in Lambda functions with Python and are exposed as MCP servers, as an MCP server using Amazon Agent Core Gateway. This service or this module of Agent Core allows us to expose either existing APIs, if you have an API gateway, an open API, or in our case, Lambda functions, as tools in an MCP server. It really simplifies that connection. The tools we have are text extraction. So the text extraction tool is using Amazon TextRack to get the text blocks and the structure metadata for the document. Then those text blocks get sent to the translation tool, which goes and sends that information again with Amazon Bedrock and Sonnet 4.6 to get that text translated. I do want to note that these two instances of Amazon Bedrock can use different models. You don't have to use the same one, so you can adjust whether for price or for better quality for your use case. Then we have the PDF reconstruction, which is simply gathering all that data and pushing that document back to S3. And our evaluation right now is just static code that's going to do the evaluation, check that text appears in the correct coordinates. So we're going to go through a demo. Yeah, we switch. Well, you'll get back that GitHub repo is at the end, so you can scan that. But here we have our translation agent, pretty simple. It's going to translate from Spanish to English. So what we're going to do is we're going to upload a Spanish PDF. This is a short story, which I've shortened to 10 pages because that's what our application supports. So now it's invoking our agent, and now it's doing the tool call. So it's extracting the text using TextRack. It's translating it with Bedrock. And then it's going to go and reconstruct, save the PDF back. And right after that, it'll evaluate, and then it's going to compile a cost report, which we'll get into more details a little bit later. So here's the translated document. So it is preserving the structure, and it's translating the text, right? So this is English, clearly. I know V1, it's a POC, it's not preserving the font, so we'll work on that. We'll add that to the backlog. But we can see the translation and all of that preserved, even the indentations and everything. Bring it back. So now that we have the POC, we want to measure the result, right? So how do we instrument this? There's many, many ways, and you can go a complicated route where you can track your CloudWatch logs, your CloudWatch metrics, and stream that through an event pipeline to then get a result of how many calls and how much time and all that. That's a little bit too complicated for our POC that we want to get quickly, so to see if we want to move forward. So if you don't have that infrastructure set up, it's not that I don't recommend it for production use, but at this stage, we just want to get some numbers, some meaningful numbers. So what we're doing is we're simply adding our metrics within the code. So here in our orchestration agent, it's the one that it's hosted, it's written using Strand's agents. There's this good metric, the accumulated usage, that gives us a number for the input and the output tokens for the whole agentic loop that agent went through. So whether it went through 10 loops, we're going to know the total amount of tokens, input and output that produced. So we're grabbing that from the orchestration agent. Then on the text extraction side, it's the Lambda function. So this one's using TextRack. TextRack charges you by number of pages. So we're capturing how many pages were put through TextRack, and which is what it charges you by, right? So then, sorry, go back.
Oh, sorry.
Then the Lambda function charges you by memory and the duration, and S3 by the API calls that it makes. So we're capturing that information. Then we jump into the translation step where we have a Bedrock. This is not using Strand, so we're getting the input and the output tokens directly from Bedrock, which we can see here. And then we have the Lambda function and the S3 as we did in the other one. Now for the reassembly, this is just the Lambda function, and it has calls to S3. And then we have the evaluation, Lambda function and S3. So we then consolidate all that information, and you can simply multiply based on the price, right? So TextRack charges 0.00015 per page. Yeah. So you do that multiplication, and you can start getting some numbers to produce something that looks like the following dashboards.
So we kind of spoiled the answer for this, but Basically, when you think about AI agent costs, the first thing that comes to mind for most people is LLM costs, right? Tokens. Tokens are super expensive. Tokens, AI agent, tokens. So this is a naive way of modeling the cost for the agent. You just consider the bedrock cost for translation and the agent core cost for orchestration. And you come up with some number. There it is on the other side of the screen. So the thing is, that's not taking into account all of the other services that we were using, that we instrumented. This is what a complete cost modeling would look like. And if you check the number, you're going to see a couple of interesting things. One, it's over an order of magnitude larger than what we had on the other screen. Number two, it's actually dominated by text track, not by the inference. So keep in mind we're testing with a PDF with just 10 pages. So this may change depending on the amount of text per page, the number of pages per document. Don't treat it like it's always going to be 10x, but do consider that in this case, text track is actually dominating the cost, not the tokens. And the other thing is that you might say, well, text track may not be the right solution in that case. You may be right. But even if we take it out, even if we completely take out text track, you're going to see that the number adds up to over 50% more than just the inference. So there are many, many more costs to agent than just the tokens. And now that we have all of the costs, this is a complete cost model, and this is what our agent actually costs. We know the business value, we know the cost, we can do the unit economics. So this is how much manual translation will cost, $15, right? According to all of our evaluation of the business value of the agent. This is what our agent costs. So these are our margins. This is how much money we are making or we are saving by having this agent. And we can multiply it by 100 documents, by 1,000, by 10,000 documents. This is how we actually evaluate how much our agent is worth.
But that is not the whole story, right? There's situations like we talked, we have the evaluation where the document's not going to get accepted. So we have a retry mechanism, and then we have a human escalation. So these are things we have to take into consideration for our upper bound cost for our whole solution. So here we can see that when it fails, so we're assuming that 95% of our documents are going to get accepted at the first try. And that 4% of the documents are going to go through an agent retry and work. So you can see we're doubling up on the price because it's reprocessing the whole thing. And then 1% is going to get escalated to a human, which is going through the retry, and then we're assuming a $7.5 cost for a human escalation. Why it's not the $15? Because the agent already translated something. There's already something in place. You already have the feedback from the evaluation gate. So they're just fixing that. So we're assuming a lower cost for the human escalation. So when we weight that cost, it comes up to $0.092, up from $0.017. So while it's still cents, if you think about it in percentage, that's quite a bit of a difference. So this might be the difference that will push you off the threshold to say maybe this is not worth it. We don't have a good margin. In our case, we still have a pretty good margin, so we're still going to move forward with this project and fix all the bugs and make it production ready. But we have a 99.4% margin, which is pretty good. So we'll move forward.
Definitely pretty good. But the thing is, this cost is not going to be your real cost. This is actually an upper bound on your cost. Because remember, this is a POC. Like, we did this in the easiest way possible, so we could measure more or less how much it will cost. Next, what we're going to do is iterate for margin. That means we're actually going to apply real serious engineering to the solution, build something better that hopefully is going to be cheaper. And again, going back to what's your first instinct with AI agents, what's the easiest way of lowering the cost of an agent? Pick a cheaper model, right? Well, not always. Like Andres was saying, there are escalations in this case. We are assuming AI agents or AI models can't get the translation perfect every single time. So we model this, again, example numbers, with two different models. Haiku and Opus, right? On both ends of the spectrum, or at least Opus was the high end of the spectrum until 2 days ago.
Yep.
That's the world of AI. So with Opus, we're going to get a much larger cost per run. Excuse me. Sorry. Much larger cost per run. But the thing is, we're going to get a lot less escalations. Haiku is going to be much cheaper, but it's going to escalate a lot more. And the costs here are actually dominated by the escalations, not by the tokens. So if we optimize for token value, we actually come up with a much larger cost. Or not much, but a little bit larger cost. Besides, we need more people, we need manual work, all of that. So in this particular case, with these particular numbers, Opus comes up cheaper than Haiku. You don't need to, this is not an answer that fits every single agent, but you do need to do this kind of analysis for your agent for each different use case. And, sorry. So now you know the unit economics of your AI agent. Now we know the cost, the actual cost, and now we know the value. We are at this point in a position to say, yeah, the value per unit is greater than the full cost to produce it. This is a good idea. This is a good agent. This is something that we should scale.
So before you try and scale your agents or build your agents, you have to be able to answer these 5 questions, right? That we went through this whole presentation. What is the acceptance criteria? What does good mean for you? In our case, target language, maintain structure, maintain meaning. What is the value per unit? What does it currently cost you? In our case, $15. What is an upper bound cost, right? You have to include retries, any type of failure paths, not just the LLM token cost. What part dominates the cost? As we saw here, the part that dominates was text track and the human escalation, definitely the human escalation. With all this information, you can take it to step 5 so you can then improve, right? So we can play around with the LLM models, use a cheaper one, use a more expensive one, and then go through your standard architectural efficiencies for cost or for latency, for performance, to then be able to improve all of this. And this is the way you can optimize your unit economics so that value is greater than the cost.
And the final lesson here is that if the value exceeds the cost, you should go to prod. If the value doesn't exceed the cost, then you should either find a cheaper way to solve the problem or find a more valuable problem to solve. Thank you.